Hi everyone, welcome back to Food Feeds. In this video, I'm going to talk about active packaging as well as oxygen scavengers, which is also a part of active packaging systems. Well, as always, I would like to suggest you to have a pen and paper with you so that by the end of the video, you have your own notes, which you can use for the future references. So let's begin. So most of us think that this active packaging system existed like just 10-15 years ago, but in reality these active packaging systems have been available since 1970s, but the only fact is that it was not widely used in food or beverage industries. So there are different definitions given by the organizations for this active packaging systems, but I would be quoting the one which is given by Active and Intelligent Packaging Regulations by European Commission. So according to them, this active packaging is described as a packaging material which is intended to extend the shelf life or to maintain it or improve the condition of the packaged food. So how this will be done is by the design it to intentionally absorb or release substances into or from the food and its surroundings. So in order to maintain these major features like extending the shelf life or to maintain it or to improve the condition of the packaged food, we need to design proper facilities in order to release, absorb the composition of the air, because that is the major key feature in storage of any food product. So now we also need to know like what exactly the changes will be made or how it is designed in order to maintain the surrounding environment in such a state that uh, the extension of shelf life is possible. So let's see what does this active packaging consist of. So typically these systems include oxygen, carbon dioxide scavengers, ethylene scavengers, moisture absorbers, flavor and odor absorbers. So wherever there's a presence of scavengers, that is, it means we remove that particular substance using them. So there will be a reason why we need to remove oxygen, carbon dioxide, or ethylene from a particular product. But also there is a reason why we need to use the moisture absorbers or flavor odor absorbers. So that we'll be studying in the upcoming slides. So currently this active packaging has been used with many food products, and also it has been in research for a long time with trial and error with the other new substances or new food products as well. And nowadays it is being used in a combination form with the modified atmosphere in order to inhibit the microbial and chemical degradation. So next we need to understand what particular active packaging system we need to apply for a particular food. So what factors will decide this? So let's see that. How to apply different active packaging. So majorly the mechanism by which the food deteriorates needs to be understood before we apply any type of active packaging solution to a particular food product. The major thing for all this active packaging is to extend the shelf life. So we need to first know about the shelf life of the food. And we also know that this shelf life of the food is dependent on various factors. The first being the intrinsic factors like acidity, water activity, nutrient content of the food, occurrence of antimicrobial compounds, which like inherent ones, redox potential, respiration rate, and biological structure. And the next one is the extrinsic factors, which includes temperature, relative humidity, surrounding gaseous composition. So all these factors together influence on the chemical, biological, physical, microbial spoilage of an individual product. So by considering all these mechanisms, it is possible for us to apply different active packaging techniques to extend the quality as well as the shelf life of the product. So whenever we refer to active packaging or any novel packaging technologies, we consider everything as one. So we do not know the basic principle applied in different packaging techniques, and we use synonymously. So one such factor is that we use active packaging synonymously with intelligent or smart packaging, which is actually not the fact. So active packaging is not synonymous with intelligent or smart packaging. So now we know what is active packaging by definition. So let's know what is intelligent or smart packaging so that we can know the difference between these two. So again, here for intelligent packaging, I have used the same definition which is given by active and intelligent packaging regulations by European Commission. So according to that, in intelligent packaging, they monitor the condition of the packaged food or the environment surrounding the food. And here the intelligent packaging can provide the assurance of pack integrity, tamper evidence, product safety and quality, and it is being utilized in applications such as product authenticity, anti-theft, and product traceability. So which is completely different from the active packaging, where it mainly focuses on the extension of the packaged food, shelf life of the packaged food, by just changing the environmental conditions surrounding it and inside the packaging material. Whereas here in intelligent packaging, it not only monitors the condition of the packaged and the surrounding environment, but it also helps us to give the pack integrity, safety, and quality. And it has a major application in these things like the product authenticity, anti-theft, and product traceability. And as for the things like how to maintain the gaseous environment, in the active packaging, we had different scavengers, absorbers. Similarly, in order to get the product authenticity, anti-theft, or product traceability, we need some other system and facilities to achieve this, right? So let's see what are they. So all these intelligent or smart packaging, it includes the indicators, which are time and temperature, freshness of a product, ripeness in case of fruits and vegetables, and the chemical reactions, like any particular substance, once it gets increased or decreased, we come to know what is the spoilage indicate. It might act as a spoilage indicator. And there is also gas sensing dyes, because you know that whenever there is a respiration going on the harvested food products, these gaseous composition will change. These gas sensing dyes will help us to see what is the stage of the maturity level or the ripeness level. So these are used. So because of the presence of these kind of sensors, a slight change in temperature or the gas composition surrounding them, or even the packaging structure of the material, there the sensors get activated, and we can come to know that it is not provided in the same quality or the packaging system that was dispatched from the industry. So it will be a great application in order to know the spoilage or even the onset of spoilage by changes in this gaseous or chemical composition and the surroundings, and also if there is a change in the packaging material. And it will be a great help in order to know beforehand about the food spoilage, onset of food spoilage or deterioration. So in this table, in one column, they have given the active packaging system, and the other column, we see that what exactly these active packaging system are applied in this particular food product. So we already know what are the factors we need to consider in order to fix a particular active packaging system to a particular food. That is the mechanisms, or the shelf life of the product is the major thing that we need to consider. So here, if you see, Oxygen Scavengers has been used in bakery goods and prepared food. So by this, we come to know the presence of oxygen in these products will cause some deterioration or some appearance problem in these food, for which this oxygen is being removed from that food. Similarly, in the next column, we can see that carbon dioxide scavenger is used in case of coffee and yeast-based goods, whereas the presence of carbon dioxide will enhance some factors in bakery goods and prepared foods. Similarly, ethylene scavenger is used in fruits and vegetables. Ethanol emitters is required in bakery goods like cake and bread. Moisture absorber in case of meat, poultry, fish, fresh fruits and vegetables. Flavor and odor absorber in fruit juices, meat, poultry, fish. So remembering these like just by reading is difficult, but you can just know the reasons why a particular gas needs to be removed or added in a particular food product. So when you know the reason, it is easier. You need not memorize it. You just need to know the reason so that you can just make out that which particular packaging system is used for which food product. So as today I'm going to discuss about the oxygen scavengers, we will know what exactly this oxygen creates a problem in particular foods due to which it needs to be removed from that. So let's know about the oxygen scavengers. As I said, first we need to know why we need this oxygen scavengers. Oxygen can have a detrimental effect on different food products. So the first thing why we need to remove the oxygen is it increases the rate of staling in case of bakery food. So that is why you saw in the table that oxygen scavengers have a major application in bakery goods because it increases the rate of staling. And also it has a negative effect on the quality of some fish. And it also contributes to the discoloration of cooked meats and herbs. And also it helps in the degradation of vitamins. And the most obvious reason is the oxidative rancidity, which causes off flavor and odors, which is common in case of cooked meat, nuts, fried food, or cheese and fat. That is like anything which includes more of fat and exposure to oxygen, then the oxidative rancidity will be an obvious deterioration fact. This rate of oxidation, it is influenced by the composition of the food and the available oxygen concentration that is inherent or how much is available and the external oxygen level, temperature, and the presence of any pro-oxidants, that is like light and metal ions, which speed up this reaction or which helps to enhance this or speed up this oxidation reactions. So basically this removal of oxygen will help us to maintain the quality of the food. So now we know the reasons for why we need to remove the oxygen. So now the question is how to remove this oxygen. So there are different methods used to remove the oxygen from a packet, including the modified atmospheric packaging and including this oxygen scavengers in the packets, combination of modified atmospheric packaging and vacuum packaging, which can be used with a high barrier films, which will hinder the oxygen passing over to. There is a limitation of this vacuum packaging because it can only be applied to a certain food types, which will not damage the structure of the product. Because since you know the vacuum packaging, complete air is removed also. So during that, the food products which won't affect with the structure with this packaging material, only for that it can be applied. The major application of this oxygen scavenger is also in the food which are in layered form, that is the bakery products, because this oxygen will be trapped inside this layered products. So whenever the packaging is completed, these oxygen, tapered oxygen will be released into the headspace of the packaging material during the shelf life. So if there is a presence of oxygen scavengers, then even when the tapered oxygen is released, these will help us to remove this oxygen during the shelf life. So basically, these oxygen scavengers can be used as an alone application or in combination with different methods. So earlier, these metals along with the moisture were used to remove the oxygen from the packets, like the ferrous sulfate, copper powder, zinc, alkali metal salts. These were used. All these oxygen scavengers are in a small sachet form. Now we'll know what are the products for which these are applied. So these are usually used in beverages like juice, tea, coffee, beer, baked products, cheese, meat, and sauces. So here you can see the packet, that is the sachet inside the glass jar. So the effectiveness of the oxygen scavenger within the packet, so how much it can remove, it depends largely on the equilibrium of the relative humidity of the food and also the diffusion of oxygen through the packaging material. So if you see this box, so majorly the effectiveness will depend upon the relative humidity of the food inside it, and also this is a glass material, right, the packaging material. So how much oxygen can diffuse inside the packaging material will also influence the effectiveness of oxygen scavengers. Coming to the capacity of oxygen scavengers, it depends on the mode of activation, scavenging capacity, and at what rate is the oxygen being removed. So now we need to understand what are the factors we need to consider to select a particular oxygen scavenger. So first is the desired shelf life of the product in which we are going to add this oxygen scavenger. Second is the oxygen content of the pack and also the oxygen content of the packaging material. So as I said, all the well-known oxygen scavengers are available in the small sachet form, which contains various of iron-based powders, which is combined with a suitable catalyst, which will enhance the rate of absorption of the oxygen. So in chemically, what happens is this small sachet which contains this iron powders, they will react with the moisture or the water which is given or present in the food product. So the moisture from the food product combines with this iron sachets, iron powders, and it forms a reactive hydrated metallic reducing agent which helps to remove or scavenge the oxygen from the packet. And it will also form an irreversible reaction which will give us a stable oxide form in the packet. And these iron powders, as you know, it is separated from the food and it is very small packet, highly oxygen permeable sachet, and they should be compulsorily labeled as do not eat. So you can see here, I think you must all have seen this in one or the other packaging products. So they will mention this do not eat label on these sachets. So the major advantage of this type of oxygen scavenger that is in the sachet form, which includes this iron powders, is that it is capable of reducing the oxygen level to as less as 0.01%. Whereas in case of modified atmospheric packaging, the reduction of this oxygen level is around 0.3 to 3%. So the first iron-based oxygen scavengers were marketed in Japan in the trade name of Ageless, which helped us to reduce it for 0.01%. And these sachets consist of fine iron powders along with sea salt, natural zeolites, and the sodium chloride solution. So now we know the metallic-based powders, that is iron. Now we'll see what are the non-metallic oxygen scavengers. So again, why we need to use this, right? So basically in few food products, the metallic taints will remain, and which is usually unacceptable in the market. So for such food products, non-metallic scavengers are used. So these include the reducing agents such as ascorbic acid, photosensitive dyes, enzymic oxygen scavenger systems, which are again incorporated into sachets or immobilized onto the packaging film surface itself. So coming to ascorbic acid, it is used as a reducing agent, and in the presence of transition metal like the copper, it can remove the oxygen. So chemically what happens here is this ascorbic acid is broken down into dihydroascorbic acid with sulfite element adding one oxygen molecule to create sulfate. So basically the amount of oxygen which is removed will depend on the level of ascorbic acid present. Even these are in the form of sachets or labels, or also it is incorporated into bottle caps. And this ascorbic acid sachet were patented by the Pillsbury Company, which claim to inhibit the growth of aerobic microorganisms. And the level of oxygen that will be absorbed by this sachets of ascorbic acid depends upon the level of the ascorbic acid present within the sachet. So one more method to remove the oxygen is by using these immobilized enzymes. So again, these enzymes like glucose oxidase or ethanol oxidase combined with the catalyst is used to reduce the oxygen level within the packets. So chemically, what happens in this immobilized enzymes is the oxygen and the moisture oxidizes the glucose into gluconodelta-lactone with the consequent production of hydrogen peroxide. And this hydrogen peroxide is degraded by enzyme catalase and it will produce water and oxygen. Though this catalase produces this oxygen, the combination of both the enzyme reduces this overall oxygen concentration in the system. So Bioca was the first company which used the enzyme-based oxygen scavenger, which generates the carbon dioxide in order to replace this oxygen in the packaging system. And even here, the scavengers are in the form of sachet and they are incorporated into packaging films as well, and is applied to different products like bakery, snack, cooked food, cured meat and fish, dried goods, and even ready-to-eat products. So there is a small disadvantage of the sachet is that sometimes these oxygen scavenger packets are accidentally ingested by the consumers, believing that it is also a part of the food. So that is why the labeling is very necessary and compulsory, where it should be mentioned do not eat. Along with in the outside packet also they should mention that as well. So now let's know a few information about how this oxygen scavenger was discovered. So basically it was discovered when nylon was laminated to PET and the residual cobalt from the polymerization catalyst led to a photo-initiated oxidation of nylon. Usually these packaging films rely on the double bond of the polymer in order to react with the oxygen. As I said now, the photo-initiated oxidation of nylon led to the discovery of oxygen scavenger films. These oxygen scavengers, which are incorporated into packaging material, they are activated when they're exposed to this UV light at a specified wavelength. And that is the reason why a photo-initiator is incorporated to prevent the reaction occurring before the packet is exposed to UV light. So what happens once it is exposed to UV light, the photosensitive dyes molecule which is present in the packaging material, they become charged and they excite these oxygen molecules within the packet and get trapped them and bond with the film. So that is how it is removed from the packet. So earlier, the traditional materials like glass, metals, which has a higher oxygen bearing property compared to plastics, they were used, but nowadays it has been, the application of these have been reduced. Non-carbonated drinks like the fruit juice, sports juice, or the sports drink, functional beverages, beer, they are all sensitive to oxygen and hence this needs to be removed from them. The UV light and the presence of oxygen will affect the color, flavor, and vitamin content of the beverages. So please note here that the iron-based oxygen scavengers cannot be used in the non-carbonated drinks or any food which is wet because the oxygen scavenging capacity is lost when it is wet. Instead of that, non-metallic reagents or organometallic compounds which have higher affinity towards oxygen, they are incorporated into the bottle caps or the closures, crowns, and they are blended into polymer material which will help to scavenge this oxygen. So there are different companies which are using these oxygen scavengers in different forms. So the Amoco Chemicals, they have developed a PET bottle with an Oxygen Scavenger, which is incorporated both in inner and outer layer of it, so that it provides the barrier of external oxygen to come inside the product. So one more company, that is Constar International, it has developed a bottle which contains the Oxygen Scavenger that binds the oxygen molecules and retains them within the container. So it will not spoil the product, but it binds with it. Like I said, in the packaging material, some of those work like either they remove it, either they hinder the entry of oxygen from external environment, or they just keep attached to it in the packaging film itself, so that it is not free to react with the other molecules present, or it is not available for microorganisms either. So this was all about the active packaging systems and oxygen scavengers. So in the upcoming videos, I'll be covering the rest of the topic. So do subscribe the channel and hit the bell icon so that you will get a notification whenever there is a new video uploaded. You can also follow Food Feeds on Telegram, Instagram, and LinkedIn platforms for frequent quiz, posts, and updates to technology and aligned fields. Thank you. Happy learning.